Hey everyone, it's Hunter with Group 9, covering Chapter 9 this week, which is creating foundations of our deployment pipeline. Starting off with the introduction here, we have 4 different topics we're going to cover this chapter, which is enabling on-demand creation of development, testing, and production environments. Next, we have creating our single repository of truth for the entire system. Next, we have make infrastructure easier to rebuild than to repair. And lastly, modify our definition of development done to include running in production-like environments. And as we focus on these 4 things, the test environments should go a lot more quickly and more smoothly, enabling faster developments to production. And over here, this graphic is taken from Microsoft Azure DevOps of how a repository would be laid out, where you have files, commits, pushes, branches, tags, and pull requests that lots of companies would use to version control their products. Alright, first let's talk about enabling on-demand creation of development, test, and production environments. So this enables developers to find and fix problems fast. There is a part in the book where it talks about the issue here, and then it says, in many cases, development teams may have request test environments in early stages of the project. However, depending on the situation, and a lot of times the test environment would be buggy or would not work many times, causing that team not to be able to actually do much work. So if we can work on this, which would basically allow the test environments to always work, it would basically have the teams be able to use a test environment and work on their side a lot more quick, and then they'd be able to again get releases to the consumer and to the development branch a lot sooner. Talks about a few different ways of how to do that. One is spinning up a new environment in a public cloud. Next, we have copying a virtualized environment. Thirdly, using configuration management tools. And lastly, using automated operating systems and configuration tools. And I like the first one, the spinning up a new environment in a public cloud, where you have, let's say you have a group of teams. You can all use the same service online, and you can see each other's code commits and changes, and see what other teams have done, and see the comments, and you can also go back to an earlier branch and work from there. Alright, next we have creating our single repository of truth for the entire system. So I also work on a project myself, which we use Azure DevOps to version control, and it's very nice. And so on the right here we see these are different branches, and if you see right here we have a development branch. So each branch in here contains different commits that we have used, and then when we're done and ready to merge to our development branch, we would create what's called a pull request, and then we can change the code and edit them from having people to review the code before it merges to develop, making sure there be no bugs. Alright, so the bullet points talking about being achieved when the developer put all their application source files, a configuration, and a version control, which would be this here. Our version control repository enables us to repeatedly and reliably reproduce our components of our working software system. And like I said, you can go into any one of these branches and run from that branch and using the code from that branch, and it would work. Alright, thirdly we have make infrastructure easier to rebuild than to repair. The book talks about an example where this guy at Microsoft said that they have tons of servers. However, when one server goes out, they used to care for it and tender it and try and make it work, and in a sense refurbish it. They realized that it's better to just throw it away and get a brand new one, and that applies in a more wide spectrum than just servers. It's also in regards to code, talking about, so if you have you're working on this code and all of a sudden you realize that it becomes buggy or there's issues that you can't you don't know how to repair or fix, it's better just to go back in time to the older version and restart, and ended up being quicker, and it saves a lot more time. Next we have modifying our definition of development done to include running in production-like environments. So I guess people have a different definition of done than what the top one says, where it should be until the code is running successfully in a production-like environment. And I believe a lot of companies out there have apps in the marketplace, and their production apps that consumers use every day, most all of them have issues and bugs, and so there's always room for improvement. However, it's very imperative that the app mainly works or mostly works in a production-like state. And that's why companies will have betas and alphas for consumers to test them to help squash out bugs. So in reality, I would say people are really never done with making their apps. There's always room for improvement. Talks about methods used to monitor and deploy products should be used in production as well as in part other production-like environments, and that is true. When you have version control, you have your production branch, and you're always working on branches ahead of that, and when you merge to it, you should always be able to look and make sure that the new branch has no bugs, so when you merge to develop, it'll become the new development branch. And basically have the mindset that you still have more work to do and you're not done until the code is 100% bug free in the production environment. So from a conclusion, hopefully we covered about creating fast and reliable flow from development to operations. We were to cover creating a common build mechanism for our environment, create a foundation that's easier to rebuild than to repair, and create quality in our processes. And this all can be achieved by using a version control. I like Azure DevOps. With Microsoft, you can get the teams to work faster and more reliable using this software. And then you can see each team's commits and changes to the code. You can go back in time to start from a production environment that was bug-free if there was an error in a new branch and a new commit, and so it's easier to then go back and to rebuild rather than try and fix the corrupted branch. And therefore, by doing these things, we will create quality in the processes. And there's a nice little graphic of development ops showing that it's always continuous. We plan, create, verify, package, release, configure, monitor, and plan how to improve it, and so forth. Alright, thank you so much for listening to this presentation. Hopefully you learned a little bit, and take care.